Hello everyone, I am Miss B. If you don't have me for geometry, I make these review videos for every test, hopefully. Um, Going through the review, making sure that you understand everything. Maybe you just needed to hear it from a teacher again. So here is my advice for studying for any test in any math class, okay? Try all of these problems on your own first. The test is just you and your brain and your trusty compass and ruler. Straight edge, not a ruler, straight edge. Try everything on your own first. Then those ones that you couldn't figure out, look back at your notes because that is still, again, like using stuff from your brain. Then come back to this video, okay? Or if you've already done all that and you're just like, I just kind of want to hear it another time, then that's what this video is for. You should not be watching this video if you haven't even started your review yet. Also, I don't think you really have a compass at home. So, okay, so I'm gonna share my screen. The quality is bad. I'm gonna let you that know right now. Let you know that right now. Quality's bad, but you have this printed out for you. Okay? So define the following terms. Radius. What is the radius? That is the line connecting the center of a circle to the edge. Center to edge of a circle. That's what's so awesome about circles is, hey, every single point along the outside of the circle is a radius distance to the center. Okay, so that leads into my definition to circle. I know it's not next alphabetically, but a circle is all points a set distance away from the center. And that distance is the radius. So I know a lot of you guys were kind of like rolling your eyes and you're like, okay, I'm making this letter U worse. I know a lot of you guys were rolling your eyes and you were like, what do you mean the definition of a circle? It's round. Okay, but a circle is literally the definition of a circle is every point a set equal distance away from center, which is the radius. Okay, perpendicular. That is when two lines intersect at a right angle. A right angle, a 90-degree angle, however you want to say that. Kind of what I like to think of the opposite of that is parallel, which is two lines that never intersect. Okay. You may have seen me or your teacher use these symbols, perpendicular and parallel. Whoa, that's a really bad one. Parallel. Sometimes I use those symbols when I'm too lazy to write out the whole word perpendicular. I'll just do that. Okay. Polygon, a closed figure with three or more segments, so straight lines. I saw some of my students wrote straight lines in their personal definition that do not cross. Okay, so when we're thinking of like a triangle, right? It's not like this. Okay, triangle. That one is more so like if I said the word polygon, would you know what that means, right? That's like a triangle, a square, a rectangle, not a circle. A hexagon, a pentagon, all that stuff. Okay. A bisector, remember that prefix bi means two. So splitting in two, but more specifically, splitting it in two halves, two sections, two halves. So a bisector is it's most often a line, but it could just be a point. A line or point. Make sure I'm on the screen. That splits a segment or angle in half. A line or point that splits a segment or angle in half. Okay, congruent. Congruent is different than equal, okay? I can draw two equal shapes right here. Hold on. I was going off of my head. Okay, these are two equal shapes. Why? They have the same area. 2 times 4 gives me an area of 8, and 1 times 8 also gives me an area of 8. These two shapes would be equal, but I would not say they're congruent. Why not? Pause, think. Why are they not congruent? They do not have the same dimensions, right? So congruent is not just equal, it is literally exactly the same shape, except it might have been like moved around or turned or something. So congruent are two shapes that are identical. Two identical shapes. Inscribed sounds like inside. To scribe means to write. So this is a shape formed by points on a circle, and the shape is fully inside the circle. Shape formed by points on a circle, and the whole shape is inside the circle. Okay, so there's our definitions. It's kind of like a brain dump. Like, do you understand these things? Do you understand what a radius is? It's not just like, oh, some measure of a circle. It's literally any line that goes from center to edge of a circle, no matter where it is on the circle, because all points on a circle are equidistant to the center. Okay? So let's do some constructions. Constructing both an equilateral triangle and an isosceles triangle. So equilateral means all sides are equal. Isosceles triangle means two sides equal. Okay, so get your trusty compass and straight edge. All right, my 3 construction moves are draw a circle, mark an intersection point, connect 2 points with your straight edge. Okay, right now I have no intersection points and my 2 points are already connected. So I'm going to draw some circles, okay? So I want to set my compass to be this distance. My radius is EF. I'm going to draw maybe not a whole circle, but an arc centered at E with radius EF and an arc centered at F with radius EF. Okay. All of the points on this line are the same distance away from F because F is the center of that circle. Every point on this line is the same distance away from E. Intersection points are important because at this point is the same distance to E as it is to F. Okay, so I marked my intersection point. Let me connect this together. Because I made those arcs using this radius, I know all 3 of these sides are the same length. They're all that radius distance EF. Okay, so there's my equilateral triangle. What about an isosceles triangle then? I might go ahead and connect those intersection points to make my perpendicular bisector. An isosceles triangle, 2 equal sides. Think about this. What is true about any point on the perpendicular bisector? Think about when you went out in the hall or I think Miss Clyde did it in her classroom. Think about when you went out in the hall and you and your classmates made a perpendicular bisector. Any point on this line, no matter where, even if it's not marked, any point on this line is the same distance to E as it is to F. So that means, hey, I could just pick any point, literally any point on that line, and this distance has to be the same as this distance. Okay, so these two have to be the same length, and it's different than EF. Okay, so that question is a direct application of, do you understand what that actually means for a perpendicular bisector? Any point, I could have put this point here, 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 and these two lines would have still been equal. Any point on your perpendicular bisector is equidistant to the endpoints of the segment it's bisecting. Also, since this is the first video I'm making this year, if I ever say something and you're like, "Whoa, Miss B, say that again." Did you know you can rewind? Did you know you can pause? Yeah. Okay. Answer the following questions based on the diagram to the right. Let's see. Okay, there we go. Name all segments congruent to AB and explain how you know they are congruent. Okay. So, first thing, take a look at AB. What is that measure? Congruent to AB. I always like to mark it with my pencil, or I have this blue pen that I use too to like differentiate colors. What is that distance? Like, is that just any line segment? No, it's a radius. Look, from the center to edge of circle A, and also from the center to edge of circle B. Okay? So, all segments congruent to AB, and why are they congruent? Well, because these circles literally have the same exact line as a radius, I know that they are congruent circles. Okay, so maybe I'll write that up here so I can use it for all parts A, B, and C. So circle A, or circles A and B are congruent. There's my claim. Think about your CER in English class. We really just have claim and reasoning here, but there's my claim. Circles A and B are congruent. Why? Because they share radius AB. There's my reason. The circles are congruent. Why? Because they have the same radius. Okay. So what are some other segments congruent to AB? Should be any radius measure. Any radius measure. So let's start. I know the radius goes from the center to the edge. So let's just start looking from the center. Okay. A to B. Anywhere else? A to C. A to D. Okay, I think that's it for circle A. Let's look at circle B. So B to A, but that's already AB. Oh, B to C, that's also a radius measure, center to edge. And B to D. Those are all my segments congruent to AB. How do I know? What were we looking for just now on that circle? Radius measures, radii. They are all radii of congruent circles. Okay? If you're having trouble with your justification, did you hear my thought process just then? Here's my answer. What was I looking for? Oh, I was looking for radii, radius measures. So that's my justification. That's what I did. They are all radii of congruent circles. Okay, so what is the relationship between AB and CD? When they say, what is the relationship? I was talking with my students about this. Because that question feels kind of vague, huh? What is the relationship? DTR. Define the relationship. What is the relationship between those line segments? Almost every time, the answer will not be they are intersecting. That is the least interesting thing about these two line segments, okay? A lot of things are intersecting here. My circles are intersecting, right? These two lines are intersecting. This line is intersecting the circle. Just saying they're intersecting, not that impressive. What is the most detailed and specific thing you can say about these two lines? CD is the perpendicular bisector. Perpendicular? Did I just say a real word? Sometimes my brain moves faster than my mouth. CD is the perpendicular bisector of AB. That's way more interesting than they intersect. And how do I know? Well, it's because this was constructed by connecting those intersection points of congruent circles. Okay. Classify at least 3 figures in the construction and justify your classification. Okay, this could be a bunch of different stuff. So I see an equilateral triangle, ABC. How do I know it's equilateral? It says justify, but I might not. This is the same equilateral construction as on the front page. So for my justification, I would say AC is equal to BC is equal to AB. So all 3 of those sides are the same length. There's my equilateral triangle. I also have a right triangle. Maybe I can like name a point here. E. Okay. B, C, E is a right triangle. Okay. And I know that because CD is perpendicular to AB. I also know ACBD is a rhombus because all 4 of those side lengths are equal. AC, CB, BD, EA. Sorry, I know my hand's in the way. And I know that because all of those line segments are equal. All right, in this construction, A is the center of one circle, B is the center of another. Identify each segment congruent to AE. Be prepared to explain why. Automatically, are these circles congruent? Yes or no? Okay. If they are, I'm going to justify it so I can use that fact later on. Circles A and B are congruent. Look, they have the same radius here. A to B is the same as B to A. So because, that's my abbreviation for because, they share radius AB. Okay. So what are my segments that are congruent to AE? Let's highlight that on our paper. What is special about that segment? It's a radius measure, AE. So what are some other radius measures? Radii. So AC, AD, AB. Again, I like to just look at the center and pick every center to edge measure. Okay, we also have BC and BD. And I could write BA, but that's the same as AB. Okay, so be prepared to explain why. So here's all my segments. Why? Why am I looking at those lines? Why were those the ones I was pointing out? Because they're radii, not just any radii of congruent circles. Because those segments are radii of congruent circles. You might notice we're saying the same kind of thing over and over again. Okay, here's our line segments. Why? You should always have a because statement if it says explain why. Here's my answer, because. Okay, well, why was that my answer in the first place? Because they are radii of congruent circles. Okay. Early lunch is over. Explain how to construct a line through C that is parallel to AB. Okay, it just says explain, but let's kind of walk through it. So the first thing I want you to think about is if two lines are parallel, they're never crossing. That basically means if I do perpendicular twice, it undoes the perpendicular, right? Parallel and perpendicular are complete opposites of each other. So if I have this line segment and I make a perpendicular line through it, and then a perpendicular line through that, it's going to end up parallel to that original line. So I'll go through this construction. There is like a kind of shortcutty way that Mr. Geiger put in his key, but the first thing I'm going to do is extend that line. Because if I want a line passing through C that is parallel to AB, let's think backwards about what that would need then. That means I would need to get a perpendicular line here. And C is not in between A and B. C is a lot closer to B than it is to A. So what I'm going to do here is to find a parallel line, I'm going to do perpendicular twice. Perpendicular twice. Okay? Oh, how do I start doing this if C is not on the line? I need to find 2 points that are equidistant to C. Okay? So let's set the center of my compass to be at C. And your radius can be anything as long as it goes past that initial line. Okay, you have to excuse me because I need to rotate my paper for this compass because it stinks. Pardon me. Oh, I hear Mr. Geiger out there. I think I just threw my eraser away on accident. No. Oh, no, it's on the ground. Okay. Not the best one. I don't have the best compass. Okay. Now I have these intersection points, which are in equal distance to C. What up, Mr. Geiger? You want to say hi? Yeah. Well, I'm talking through the review. Okay, bye, Mr. Geiger. He didn't want to say hi. These 2 points are in equal distance to C, but B and A were not, right? C was a lot closer to B. So I'm gonna mark these as D and E. And now I'm gonna kind of ignore A and B. I'm going to make a perpendicular bisector with D and E as my endpoints. Okay, so here I go. What? Okay, yours will probably look different than mine because we all might have different radii for circle C. My C got lost. Okay, it might go off the page, but that's okay. You only need 2 points to intersect. Mine are extremely close together, but you can intersect going through point C. There we go. Okay, so this is a perpendicular line. Might not really look like it. My compass work is a little inaccurate sometimes, but as long as your teacher can follow your constructions, that's the point. Okay, so this line is perpendicular to my original one. Now I need to get it perpendicular again so it'll match the first line. Okay, so I'm going to turn my paper. And what I'm going to do is mark these intersection points here. Why am I going to do that? Well, these points are an equal distance to C because they're on the edge of the circle and C is the center of the circle. Okay, so if I make a perpendicular bisector using these 2 points, it will go through C. All right, so let me do that. Again, if it goes off the paper, that's okay because you can always connect it through point C. But you do need 2 points to connect together. Okay, there we go. Make sure you're doing point C and not your original intersection point. Mine ended up pretty close together. There we go. Again, mine is a little bit off. It's okay. But these are perpendicular to each other. So that means this and my original line have to be parallel. Pretty cool. Pretty cool. And yeah, what is the relationship between all of those lines? Maybe let's label, so that was line AB. Let's just do line L, M, N. Okay. Line L is parallel to line M. You can call it AB. I don't know, I was just lazy. Line N is perpendicular to lines L and M. Notice that if I'm saying line L, that's a lowercase l, and that's just showing like any line. If it's a line segment like this, it has to be those 2 capital letters next to each other. So line L is saying this entire line, or line M is this entire line, not just from A to B. Okay. Zara and Catherine were asked to construct equilateral triangles with only a compass and a straight edge. Zara doesn't believe that there's more than one way, and Catherine ended up making an isosceles triangle. So Zara's like, this is the only way, girl. That is not right. Is Zara correct? No. Zara is wrong. Zara is wrong. Sorry, Zara. Zara is wrong. So notice that this is our hexagon construction, right? So all of these points are equally spaced. And because Catherine is skipping exactly 1 every time, like this, skip over C, skip over here, okay, that guarantees that those side lengths are congruent or the same size. Okay, Zara is wrong by equally spacing the points. I know my hand's in the way. By equally spacing the points using a hexagon construction, this also makes an equilateral triangle. You too can make an equilateral triangle if you make a hexagon. Okay, fill in each of the following are less than, greater than, or equal to. Maybe it's been a while since you've seen those symbols. Remember, the alligator eats the bigger one. Okay, so looking at this, AC compared to AE, and I'm literally talking about how long that segment is, okay? So AC compared to AE. Well, let's really break that down. A to C is center to edge. A to E is also center to edge of the same circle, so those have to be equal measures, okay? This would be a good place to practice your sentence stems. Why are they equal? Because they are radii of the same circle. Okay, I'm not going to do that for every single one, but if you want a little extra practice with your justifications, do that for all of these. Like get a scrap piece of paper. Okay, HC to HA. Okay, well, C is in the center. Let's see, HC and HA. HC is definitely shorter than HA. Yeah, that's definitely a shorter distance. EG and AB. Okay, so here's EG and AB. So AB is a radius distance, right? AB is the radius of circle A, but EG, that's not a radius or a diameter, that's nothing. Okay. But I know that this distance is the same, right? BE is the same as BG. So this should be longer than just the radius. Okay, CB versus CD. Okay, well, CD, center to edge of just one circle. So this is the radius. C to B is the diameter of circle A, edge to edge going through the center. So CB is way bigger than CD. All right, DE versus FG. Yeah, I would say that those are the same length. Okay, they're constructed very symmetrically. They have a symmetric construction in circle A, so they should be the same length. This is kind of wiggly. That should just say equals. Okay, AE and BE. What? That's what we were just talking about. Those should also be equal. All right, last page. 2 constructions left. MSB's got to eat lunch. Okay, use the straight edge and compass moves to create a hexagon. You could do it like super crazy like Catherine did here with all the circles, but I'm just gonna kind of use the arcs because what I'm gonna be looking for are intersection points, right? So remember, our big 3 construction moves are draw a circle, mark an intersection point, or connect 2 points. Well, those can't be done here. I already have a circle. There's not a second point to connect that to, and it's not intersecting anything. So like, what do? Oh, my circle definition. Any point on this circle is an equal distance to the center. So I'm just gonna mark whatever point I want. It doesn't matter where your initial point is because anywhere on the circle it is will be the same distance to the center because of the definition of a circle, because that's the radius. Okay, so what I'm going to do is let's set our compass to be that radius distance. Okay, and I'm going to put the pointy end of my compass on the point I just created to make kind of an intersection point. And I'm just going to draw an arc on the circle. Again, you could draw a whole circle, but look, now I just made another intersection point that is the same distance. What's up? Sorry. Okay. Now these are an equidistant. Like we can make our equilateral triangle right here, right? Because all of those are radius distance away. So I'm going to keep that same distance with my compass, and I'm just going to walk around the edge of the circle, okay? So making this new intersection point my center. Okay. There we are. Again, should be the same distance to the center and to this last point. Okay, so let me do it again. My new intersection point that I just marked is now the center. Oh, if I could use my compass right. There we go. Okay, my new intersection point I just made is now the center. Sorry, I have to move my paper around so much. I hope you're not getting busy. Okay, and again, my new intersection point I just made is now the center. And I had the same radius that whole time. And you can do it again and it should line up with that last one. But to make this an actual hexagon, connect those points up. This is an example of an inscribed hexagon, an inscribed shape. You can see all, oh, that was a little crooked. All of the points are on the edge of the circle and the shape itself is inside the circle. Sweet. There's my hexagon. And from here, you could get an equilateral triangle two ways. You could connect every other point, or you could connect 2 points to the center and have that be your triangle. Either way. All right, last one, bisecting an angle. Okay, again, think about our moves. Draw a circle, mark an intersection point, or connect 2 points together. Really, the only thing I can do right here is draw a circle. Remember when we did this nonsense? The first thing I did was draw a circle centered at C because I knew I wanted the perpendicular bisector to go through point C. Well, if I'm bisecting an angle, I'm going to want it to go through that vertex of the angle, B. So the first thing I'm going to do is draw a circle centered at B. A lot of my students were making the mistake of making this the radius of B. But if that's true, look what will happen. That goes past point A. So you need to choose a radius so that when you draw your circle around, it intersects both rays of the angle. So if you want to set it between 2 points, set it to the distance of the shorter side. So AB is shorter than CB, so I could connect it there. Or any distance that's shorter would also work, as long as your circle is going to intersect both sides. I'm just going to set mine to be AB. Oop. I have to spin my paper. Okay. So now I have this point, again, one of our moves is marking intersection points, right? That one and this one here. Maybe I'm going to call it point D. So here's A and here's D. If I were to connect these together, maybe I'll do it with a dashed line. Okay. I'm going to treat A and D as the endpoints of a perpendicular bisector here, because then it should go through point B. Okay. So now that I've created those points, they're equidistant to B, just like these 2 points were an equidistance to C. So now that I know B is exactly in the middle, because these are both radii, I'm going to construct a perpendicular bisector using A and D as the endpoints. Okay, so let me do that. And if it goes off your paper, it's okay, as because we have B that we could also connect it to. But mine didn't, so yours shouldn't either. Okay, so I did 2 circles with radius AD, one centered at A, one centered at D. Here's my intersection points. Line it up, make sure it goes through point B. And there's my angle bisector. You can mark if those are congruent angles. There is my angle bisector. cutting that angle in half. This one was a little tough because all the ones we did in class were all acute angles, right? So that's it. There's your review. Study up. Like I said, hopefully this was helpful. I know you probably don't have a compass at home, but stay tuned. Hey, subscribe to my YouTube channel. I'm trying to beat Miss Cass and Mr. Cunningham, okay? I want more subscribers than them. Maybe more subscribers than them combined. So subscribe. Like, I don't think you can comment. I don't know. Like, comment, subscribe. Bye guys, good luck on your test.